We are Team 34. Welcome to our SOTA storytelling project video. We are working with NTT Data and we plan to deploy our system at Great Ormond Street Hospital. At any single moment, there are countless children who stay in hospital for pre- and post-treatment, often for prolonged periods away from their friends and family. As a request from Great Ormond Street Hospital to tackle this issue, we plan on using SOTA, a humanoid robot, to provide a source of social interaction to such children. SOTA will welcome children to present their favorite toys, and in response, SOTA will return an engaging and interactive storytelling experience. The key requirement of our project involves SOTA being able to detect what object is being held in front of it and select a related story to tell. Another key requirement is that the system is able to simultaneously visually display the stories whilst narrating over them. Speech recognition, along with servo movements, will be also essential in SOTA interacting with the children. This is the system architecture figure for our project. The user in the class diagram is the children. They first show SOTA an object. After children show the object to SOTA, SOTA will take a picture and send it to the local server program. The server will then send the captured picture to Google Cloud Vision and ask it to do the recognition. The results are then sent back to the local server. The server will then send a copy of the result back to SOTA. Meanwhile, it picks up an appropriate set of illustrations from the story database based on the labels given. When SOTA receives the labels, it finds the corresponding story from the story assets and then begins to tell the story. During the storytelling, SOTA will ask some questions to the children. Using the voice recognition library in SOTA, it can capture and understand keywords in the children's answers and interact through speech, movement, LED flashing, or just continuing with the story. For image recognition, we use the Google Cloud Vision API. The process of recognition takes place on the Google server. We send the yet-to-be-processed image to the API and wait for the result. The result is an array list of strings, and each string is a tag or label corresponding to the object detected. We use Sphinx 4, a Java speech recognition library, to implement SOTA's speech recognition. The library and code is all stored and run locally on SOTA's hardware. The code utilizes the inbuilt microphone on SOTA. Sphinx 4 also requires a grammar file, which we can update with new words and sentence structures for SOTA to recognize. We also used HSQLDB, which is a Java-based SQL library. We need this to save the relationship between the stories and the returned labels of the Google Vision API. The database consists of the stories table, tags table, and finally the tag stories table to normalize the database. Additionally, we have a SOTA story script file, which we use to dictate how SOTA will tell a specific story. Each line of the text file represents a phase in the story, followed by movement, the speech, and finally whether or not SOTA expects an answer at the end of this phase. We are using JavaSocket to transfer data between SOTA and the local server program. SOTA will convert the captured images into byte arrays and then pass it to the local server. The server will choose the specific story name, and this is passed as a string. The byte array is then wrapped in a JSON file and is sent to the Google server. Next is a demonstration of the key features of SOTA. These features include image recognition, speech recognition, robot movement, and choosing the appropriate story based off the object detected. The SOTA system initializes with a wake up command.
Hello, this is SOTA. Taking photo, please hold the object still.
At this point, SOTA takes an image of the Rubik's Cube and sends it to the Google API.
Nice photo. Feel free to move the object.
The Google API returns the label Rubik's Cube, and now a corresponding story is played.
You showed me a Rubik's Cube.
Here you can see SOTA's movements to interact with the children using its servos.
The story is called 7 Colors of the Rainbow. What are the 7 colors of the rainbow? Red. He wears a red shirt. Orange. What is orange in this picture?
Cat.
By looking at our custom SOTA story script file, you can see that we are now in phase 5. Movement is -1 for no movement, speak is 5, for the audio file 5, and the answer it is expecting is cat. So SOTA will wait for cat before the story continues.
Yellow. What is yellow in this picture?
Egg.
Green. What is green in this picture?
Frog. Frog.
Blue. What is blue in this picture?
Sky.
Indigo. What is indigo in this picture?
Grapes.
Violet. Violet is the best colour. What colour do you like?
Red.
That's the end of the story. Do you want to show me another toy?
No.
See you next time.
SOTA prompts the user if they want to play another story. Wei said no here, but if he said yes, we could show another object to the robot and the loop would continue. In conclusion, we are proud to have met the requirements and produced a functional proof of concept despite the daunting complexity of the overall system. However, we are aware there are improvements that we can work on, such as improving the accuracy of the voice recognition and adding more interaction between SOTA and the young patients. In the future, we plan to add new functionalities to fully utilize SOTA's hardware and make stories more engaging and interactive, such as SOTA detecting children's movement and acting accordingly. Once this system is successfully implemented in Great Ormond Street Hospital, we hope that similar systems can be implemented across many hospitals, raising the standard for emotional and mental care for physically suffering patients worldwide.